you, hopefully, you just tried these problems. Can you go ahead and, anytime we do final review openers, can you also grab out a colored pen?
Yeah.
Because, couldn't you, if this is a final review section, couldn't you write yourselves little notes, right? Now, I am going to also do like a separate without you guys, because it's sometimes hard, especially if you're watching the recordings, et cetera, to focus. I'm going to do a quick recap of all these problems in one condensed final review video and post it to Google Classroom probably next Wednesday. So as you're doing final review problems, like for homeworks, you can listen to my videos also. But grab out a colored pen because as some of you just said, like, oh, dang, this was a long time ago, right?
Yeah.
So if you have, I see a couple of you with your green books open. If you have your exponent rules open, Jonathan, focus. Hopefully you realize with your colored pen, here's what I would do. Whenever there's a multiply, you add. Whenever there's a multiply of like bases, you add. So the y's are like, and so I'm going to go ahead and do y to the 3 plus negative 5. Now, it's still a negative 5. But 3 plus negative 5. Well, what's 3 plus negative 5? Y to the negative 2, right? So we have our adding. That's our quick heads up. And that would get you almost to the right answer. But the final is going to be multiple choice. And here's the problem. In the directions, doesn't it also say positive exponents?
Oh. Yeah.
How can we take an answer that is valid as a negative number and make it positive? We can just
Flip it.
There you go. So maybe you should also write for yourselves a quick little positive exponents. If you have a negative exponent, you flip. Which means, wait, flipping, there's no bottom. Well, not yet. Put it over 1, and then there is. You can put anything over 1, right? So we put it over 1 and say, you don't belong, the negative exponent. It's not that we're like being mean. We're just saying, okay, no. You will work better in your proper place. So we go ahead and say, since y to the negative 2 has a negative exponent, we flip. We cross the line, change the sign. And then if we took away the y squared, because of that little negative, well, what's left on top? We don't technically flip. Instead, we brought him down, and then we had what remained. 1 over y squared. That'd be the final answer. What are the two things you need to remember? Add, and then negative exponents, and you can flip. How about for number 2? The reminder is not add. The reminder is
Multiply.
When dividing, you subtract. No multiplication yet. When dividing, you subtract. So, what's my subtraction going to be?
3.
Like basis, good. Careful. 4 minus 7 is a 3, but what kind of 3? A negative 3. So x to the negative 3, hey, it's another negative, so what do we have to do? Flip. So we can put that over 1, and if we flip that down, we would have the x cubed. And we need to do a little bit more review so that you guys aren't just flipping those two. That's going to mess you up in some problems. But for right now, the negative exponent means bring it down. Or if it's down, bring it up. Now, Andrew, now it's time for your hint for this next number 3, a power to a power. Multiplication, you add the exponents. Division, you subtract the exponents. What do you do when you have powers to powers?
Multiply.
Now it's multiply. Good. So now multiply. That's our hint. And some of you might also want to write in distribute. There's technically 2 different things in that green book that you have to remember. Distributing and multiplying. Now, I'm going to rewrite the problem because it kind of just got all messed up. So we have x to the 0, y. What was it? Y.
2.
And then all of that was cubed. Okay. So we could bring this little power to a power to both. It'd be 0 times 3 and 2 times 3. Now careful, it's not point, it's not a decimal, it's just times. You can put little like old school multiplications if you want. But technically this little cube has to come into both. But wait a minute, what's 0 times anything?
0.
No. And then 2 times 3 is 6. Wait, what do we get to do with anything to the 0 power? I like this one.
Add 1.
Becomes a 1, becomes a 1, right? So anything to the 0 power is a 1. Maybe you should write that as a quick little hint. And 1 times, well, anything times 1 is itself. So y to the 6th is that final answer. Are we okay?
Wait.
So we distributed. Power to a power, we had to multiply. 0 times 3, 2 times 3, and anything to the 0 power just becomes a 1. We like that one. Nice. whenever the exponent is a 0, that whole little piece becomes this. Yeah, good. Now, number 4, guys, is the grand old, like, big mama problem that's messy. So let me just zoom in. We're not going to necessarily write hints. We're just going to see if we can try it step by step. But number 4 is kind of like a man. If you can do this one, you can do anything. So if we were to try to go ahead and bring this in, maybe some of you guys forgot that if there's no power shown with a piece, there's an understood 1. So it's 2 to the 1 and 5 to the 1. It's 2 to the 1 and 5 to the 1. And then this is technically, look at that parenthesis, it's going to be this multiplication again and this distribution again. So it kind of goes for both that problem and this problem. So I'm going to have 2 to the 1 times negative 2, x squared times negative 2. If you want, you can put little parentheses because it's starting to look kind of messy with that negative in there, if that helps. 5 is going to be raised to the negative 2. And then y to the 4th is also going to be times negative 2. Now, when I go ahead and start distributing all of this, I get 2 to the negative 2, x to the negative 4, 5 to the negative 2, and y to the negative 8. Ugh. What do you notice? And it's not always true, but what do you notice about each and every piece? What do they all have with their exponents? So how do we flip all of them? Yeah, we literally just, the bottoms go to the top and the tops go to the bottom. Anyone that has a negative exponent needs to cross the line. So he's above, he has to cross the line to below. And whenever you cross the line, you change the sign. Whenever it crosses, it becomes a positive exponent. Some of you guys in the back, sorry, it's getting low for you, so let me go ahead and scroll down. So who else is going to go down? X to the power of positive 4. Good. When you cross the line, you change the sign. What's coming up? 5 to the power of
10.
And y to the power of. Now at this point, all you got to do is be like, wait a minute, 5 squared. That's a thing I should know. What's 5 times 5?
25.
Y to the 8th? I don't know. It's a variable. 2 squared. It's a thing I should know. It's 4. Do you see it? It was nasty, it was gross, it was involved, but we got it. It was nasty, it was gross, it was involved, but we got it. Now guys, do we have more review we need to do? Yes. This was just a little baby scratching of the surface to say like, hey, there's a thing called exponents. Once upon a time, we had to learn them and be able to do. Are we coming back to it? Definitely. If you have questions on the opener, come see me today. But don't worry, next Wednesday we'll also be reviewing chapter 6. Cool? I want you guys to grab out your notes. And as you grab out your notes, before you put away your homework spiral, can you just check and see? Can you just check and see? Do you have 2 homeworks from page 423? As you get out your notes and as you get ready to go, check really quickly before you put away your homework spiral. Do you have 2 homeworks from page 423? They're back there on the back. Numbers 1 through 4, 32 to 35, and numbers 5 through 12. If you have both those pages, you guys are good or at least for the homework from the break. It was technically Wednesday night's homework and Thursday night's homework. If you have 2 pages, you're good. You're going to get 100%, so you're ready to go. If you're like, I only have 1 or I have none, can you find them for tomorrow when I check it tomorrow and give a little bit of grace in case some of you guys got disorganized over break? Does that sound good? Okay, if you have them both, great. You're going to have hundreds on them tomorrow. It's back there on the board. You can take a picture of it before you leave. But if you don't have one or the other, please, please, please have them ready to go for tomorrow. I know after break sometimes it's really hard to be organized. So I'm going to go ahead and freeze the screen. I want you guys to go straight to notes. We were going to grade homework, but let me extend that 1 day of grace for some of you guys that got distracted or just forgot, didn't check your Google Classroom. The break was long. Section 8.2. We're still graphing those quadratic parabola guys. The guys that kind of describe the motion of a yo-yo, or the shot of a basketball, or the throw of a baseball, or the kick of a soccer ball. Sure, we can do all of it. Even to some extent, the flight of a plane. Anyway. We're going to keep graphing parabolas, but one little baby thing has changed. Super tiny. And it's going to have a big effect. English time. Effect. E-F-F-E-C-T. Result. It's going to result in something being different. Now, the nice thing is, if you guys remember from before break, we were doing tables. I know we had the retest on factoring, but for 2 days we worked with these parabola guys. So if you remember these tables, we plug it in, and we simplify. We plug it in, and we simplify. So let me go ahead and just get it started for you guys to plug it in. You need to plug in each of these different x values into your function, and when you plug them in here, you also need to plug it in here. This first one, the f of, is just a snazzy notation. So these little blanks are just saying, hey, who do you want to plug in? -2? Sure, I can do that. -1? Sure, I can do that. So take a second and see if you guys can match up with me if you were to plug in each of those x values. And then if you're like, hey, I think I can plug in, PEMDAS, square before you subtract. Square before you subtract. All right, I'm going to plug in. I'm going to show you what happens when you do plug in, I should say. In just a second, so 30 more seconds. Plugging in each of those x's, squaring and then subtracting. Squaring and then subtracting. If you guys finish the points, go ahead and graph them. Remember, they're x's and y's, and as we talked about, it's like an elevator. It's like an elevator. X is which elevator to go to, going right or going left, and then the Y shows how high or how low to go. Okay, plugging in -2 and squaring it would be a +4. -2 is 2. A +4 minus 2 is 2. Plugging in -1 squared would be a +1. -2 is -1. Plugging in a 0 squared is 0 minus 2. And 1 squared, 1 minus 2. And a 2 squared, 4 minus 2. If you guys remember from last week, it was 2 weeks ago, it was kind of a shortcut too, because what's on one side usually happens on the other side, at least all the ones we've seen so far. But just in case you're like, I didn't get those numbers, remember, you're having to plug in the -2 squaring, or the -1 squaring, or the 0 squaring, or the 1, or the 2. And PEMDAS says, square then subtract. Okay? Exponents, then multiplication. Oh, there isn't any. Okay, addition, subtraction. So 4 minus 2. 1 minus 2. 0 minus 2, 1 minus 2, 4 minus 2. Okay, double check your plugging in. Once you have it, can you graph for me the x's and the y's? Each of these is an x and a y. If you guys need to for your brain, if this is too confusing, you can rewrite it as y. That's okay. You're not wrong. It's helpful for your brains. You can think of it as a y. That's okay. What changed with my parabola? What changed? My parabola, what changed? Here, Armando, what's up? Oh, do you see what I wrote right below it? So for this one, I wrote negative 2 squared minus 2 because I'm following this pattern. But you have a little hesitation. What this means is whoever's in this spot gets plugged in. So it's like it's an empty blank. Variables are meant to be plugged in with numbers. So I need to plug in negative 2 into that. So PEMDAS says square first. See it? So I did that with characters. And you can kind of see my work there. Good. In case it helps, this is how I was just explaining to Armando. Remember this x is a variable, it's an unknown, but when they tell us who to make x, now it's known. It just needs to go fill that spot, fill that blank. Okay, let's see if this makes sense. I'm going to go ahead and graph the points, and as I graph the points, I want you guys to check out a pattern that we're going to go ahead and be able to see and talk about. If you graph these correctly, going to elevator -2, up to floor 2, that would be right there, or elevator -1, down to 1, or elevator 0, down to -2. And then, if you guys notice the shortcut, you get to copy. 1 is -1, 2 is 2. We could keep on graphing and do 3 and -3 and 4 and -4, and we would keep on getting more, but some of you already see that concave up like that. This isn't like a basketball that's going for the hoop. This is instead maybe like a yo-yo that's like being thrown down and coming right back up. But what's different is, ooh, what's this word over here? There was a shift. Now maybe you guys have to go back in your notes to realize, but all of the ones that we saw in section 8.1, all of them hit at this point, 0, 0. Some of them were facing down, some of them were facing up, some were like basketball throws, some were yo-yo throws, but either way, it was always at this little point 0, 0, but what changed when we added this little extra number? Now, it was a negative number, but when we did that extra addition of a negative, didn't it all go down to? That's what's going on whenever you add something on the outside of a square. So if this little number over here, if you're adding a positive number, you're going to shift up. And if you have a negative number, you're going to shift down. You can also call it an upwards shift. You can also call it a downwards shift. And so what would be like a proper way of explaining what just happened over here? Because I asked you guys, like, what changed? And I know it's hard because we haven't done parabolas for like a week and a half. But how we can explain it is there was a vertical shift. Vertical means up, down. Do any of you guys ever keep track of your stats, like in PE and stuff? If you have a vertical, isn't that like how high you can jump? Does anybody know they're vertical?
Okay. 1 foot.
1 foot?
No.
No, 1. That's not even vertical.
Well, it is.
Good try. Volleyball players usually know they're vertical because it's like how high they can get up. Anyway, maybe basketball players don't really measure it. Volleyball players do. But your vertical is like how high you can jump. Anyway, vertical, up, down. It's a shift, but in this case it was downwards. Half your coaches is okay with it. But for some of you guys, like, I can touch the hoop and that's all you really care about. Anyway, downwards too. I'm bad. Anyway, it'd be a vertical shift downwards too. So each even without making a table or graphing at all. Even without making a table or graphing at all. Can you guys tell me what you think would happen with this guy? If it's x squared plus 3 instead, what do you think is going to change? Ooh. Say the whole phrase though. A vertical shift upwards by 3. Good. So if we can get the pattern down, maybe it's not going to be that big of a deal. Now, what would have happened if we had plugged in? Well, do you see how the x's are blank? Because in your homework, it's like graph it, and you get to choose. Do you want to do -2, -1, 0, 1, 2? Okay. Do you want to do something like, I don't know, -4, -2, 0, 2, 4? Sure, just do something. Usually keeping around 0 is pretty safe. For section 8.1, 8.2, 8.3 gets a little harder. But we would do the exact same thing of leaving a space, squaring, and then adding 3. Of leaving a space, squaring, and adding 3. And what would happen is we'd have like 16 plus 3 is 19 here and here. We would have 4 plus 3 is 7 here and here. We would have 3. But what we would see is that this thing would end up, I know, people are going crazy outside, getting this vertical shift. Now guys, there's one more thing you're going to see, and we have still like 3 more minutes. Did it shift up? Yep. By 3? Yep. Hey, I think we got that. That's not too bad. The other thing I want you to see is, okay, what if they ask us for this thing called the zeros? What if they ask us for this thing called the zeros? And I'm going to take this example that we just kind of did quick and say, what if they give us x squared plus 3 and they want the zeros? Or what if it's like that very first one that we had, which was x squared shifted down to? Check it. It's so easy. They say find the zeros. What are we supposed to set it equal to? It's as easy as that. Makes sense? Yeah. Not plugging in 0, but setting equal to 0, which means you just take it and say, you want the zeros? Okay, fine. I don't get what the big deal is. Oh, wait. Maybe there is a big deal. Remember, this section is called graphing. Zeros are the intercepts of the x-axis. Zeros are the places where the parabola will hit the x-axis. And maybe that means nothing to you. But maybe in physics, the x-axis is actually the ground. Negative numbers are holes in the ground, and positive numbers are above the ground. So if zeros are where you hit the ground, maybe it is important to know, like, hey, if I throw this at a certain velocity, when is it going to hit the ground? Where is it going to hit the ground? Anyway, super important in physics. Zeros. We know whenever you set something equal, don't you just solve for x, get x alone? Solve for x and get x alone? And we have a couple different ways to do it. One way is to try to solve it exactly as it is using a square root. We could subtract 3, we could subtract 3. I saw a few of you guys on the retest trying to do that sometimes with the back. But does anybody know how to get rid of a squared? Yeah. But when you square root, there's something nasty that happens. It actually has to do with something called an absolute value. Long story short, you have to do like a little plus or minus guy. But does anybody know what's going to happen in your calculator when you do a square root of a negative number? It's going to freak out on you and say it doesn't work. There are these things called imaginary numbers. And if you try to square root a negative, sometimes the answer is going to be none. Why? Is this guy ever going to hit the ground? No. Oh, it made sense. This guy, though, if you guys move that 2 to the other side, x is going to equal the positive square root of 2 and the negative square root of 2, which you guys could get as decimals. You guys could get as decimals. They would just be kind of nasty numbers, but they're legal and they're true. All right, kiddos, homework. Let me go ahead and show it to you up on the board. You're going to be talking with this new snazzy language of vertical shift upwards or downwards from what you see in the problems, maybe doing some tables and graphing, and maybe trying to find that square root button on your calculator. But there we go. Remember, it looks nasty, but at the same time, I chose a few from there, a few from there, and a few from there.
Oh, that's what I did on the break.
Oh, you have it done?
Yeah, so I
Stop right now.
only because I did for break instead of.
Alright, guys, you can take it off. I didn't write it on the board. I'm sorry. It's on my phone, though. It's ready to go. Some of you, I guess, did it over break. You're on top of it.